Hello, seventh graders, and welcome to a new chapter. In chapter 5, we're going to be talking about ratios and proportions. I think ratios and proportions are definitely something that are used outside of school. Like once you graduate, you'll see ratios and proportions used a lot. So I think there's a lot of problems that are very applicable to your future. That's one of the reasons I like this chapter. Okay, so we're going to look more specifically at ratio tables this chapter. And we're going to see how ratio tables can represent equivalent ratios. So we're starting with our key idea here. It says a ratio is a comparison of two quantities. The value of the ratio, A to B, is the number A divided by B, which describes the multiplicative relationship between the quantities in the ratio. For example, 2 snails to every 6 fish, or 1/2 cup milk for every 1/4 cup of cream. Okay, this is something you see a lot in cooking. Okay, and algebra says the ratio A to B can be written as A colon B. Okay, and so notice that a ratio can be written 3 different ways. It can be written with the word to, so something like 5 to 10. Say for every 5 girls, there are 10 boys. That's a comparison of two quantities, girls to boys. You could write that with a colon. You could say 5 to 10 this way, or you could say 5 over 10. Okay. Notice that whatever comes first also goes in the numerator of your fraction here, right? So a ratio can be written as a fraction, or with the colon, or with the word to. Lots of different ways to write a ratio. All right, let's look at the first example here. It says you make flubber. Ooh, some of that looks fun to make sometimes. Using these ingredients. Here's the flubber ingredients. Write the ratio of cold water to glue. Cold water to glue. Okay, so if I look at my ingredients here, cold water, I need 3/2 cups of cold water to every how much glue? 2 cups. If it's helpful, and in this case, you don't have to write the cups. You can just write 3/2 to 2. Think of 3/2. Another way to think of 3/2 is 1/2. So for every 1/2 cups of cold water you use, you need 2 cups of glue. So you need a little bit more glue in your ratio here. Okay. You could also write that this way, 3/2 colon 2. Or remember, you could write it as a fraction, 3/2 for every 3/2 cups of cold water you use 2 cups of glue. Okay, either one of any of those would work for that ratio. Letter B then says, find and interpret the value of the ratio in part A. Okay, so when it wants us to find and interpret the value, this can be kind of tricky. All it means is to just divide and say what it means in the context of the problem. So it means to take 3/2 and divide that by 2. Remember, it can be helpful to write it out sideways, or horizontally. 3/2 divided by 2. Remember, you can write any whole number as a fraction by putting a 1 in the denominator. And then go back to 6th grade and remember how to divide fractions. I like to use that acronym keep, flip, flop. So keep my first fraction the same, 3/2. Flip my division to multiplication, and flop the second number to its reciprocal. So make the denominator the numerator and the numerator the denominator. Like that. Okay. Now I can multiply across. When I multiply fractions, I multiply my numerators. So 3 times 1 is 3 over 2 times 2 is 4. So we just found the value of this ratio is 3/4. And now it wants us to interpret that. So what does that mean in the context of this problem? Well, that means, so you can say, so the amount of, where we found the ratio of cold water is 3/4 the amount of glue. And that makes sense. We said that in the beginning. We thought of 3/2 as 1.5 cups of water to every 2 cups of glue. We're using a half more cup of glue than water. When we divide those, the amount of cold water is 3/4 the amount of glue that you used. Okay, so that would be my final answer, 3/4, and the explanation here is how I interpret it. Right, go ahead and pause the video now to try the try it number 1 and see how you do. Okay, it says you mix 2/3 teaspoon of baking soda with 3 teaspoons of salt. Find and interpret the value of the ratio of baking soda to salt. So notice how the directions are the same. Find and interpret the value of the ratio. Okay, so it wants to know the ratio of baking soda to salt. So if I were to write that as a fraction, it would be baking soda on the top and salt on the bottom, because my first number is my numerator and my second one is my denominator. So I have 2/3 teaspoons of baking soda over, I have 3 teaspoons of salt. So that means I need to take 2/3 and divide that by 3. 2/3 divided by 3, and 3 as a fraction is 3/1, right? How I divide fractions is I use the acronym KFF, keep my first fraction the same, flip my division to multiplication, and flop the second fraction to its reciprocal. Okay, now when I multiply, I can multiply top times top and bottom times bottom. So I get 2/9. Okay. And when it says to interpret that, again, write out this sentence. So the amount of, and this time it's baking soda comes first, is 2/9 the amount of salt. Okay, just like above. Let's move on and try the next example. But in this one, we're going to use a ratio table. So let's look at some vocab first. 2 ratios that describe the same relationship are equivalent ratios. The values of equivalent ratios are equivalent. You can find and organize them in a ratio table by, and I do not like to do this. I'm going to cross that out because that confuses a lot of kids. You can do that, but you add or subtract different quantities, and it's not as easy. I'm going to tell you, and there's not many times that I tell you to do this, but this way is by far the superior way. Trust me on that. To multiply or divide each quantity by the same number to keep your ratios equivalent. And I'll give you an example. Say I have a pizza and I cut it into one piece on the left, one piece on the right. It's a really big piece, and I eat half of that. That's represented by 1/2. I ate 1 out of the 2 pieces. That's the same as if I had another pizza and I cut it into 4 slices now, and I ate 2 out of those 4. That is the same amount. That's what they're saying here. The two ratios describe the same relationship. 1 to 2 is the same as 2 to 4. Why? Well, I multiplied both my top and my bottom by 2. This is the same amount. Okay. That's what we're going to do in the next couple examples. It says find the missing values in the ratio table and then write the equivalent ratios. So I'm comparing cups and quarts here. For every 3 cups, I have 3/4, 3/4 quarts. Okay? So how can we find these equivalent ratios? I'm going to use multiplying and dividing each quantity by the same number. So let me ask you, how would you go from 3 to 12 using multiplication? Well, a lot of you would say by multiplying by 4. Okay, so you multiply this bottom quantity by the same. Multiply by 4 to keep these two ratios equivalent. Okay, so 3/4 times 4. If you can't do that mentally, write it out. 3/4 times 4 over 1. 3 times 4 is 12, over 4 times 1 is 4, and 12 divided by 4 is 3. Okay, so 3 to 3/4 is equivalent to 12 to 3. Some of you now might look and say, okay, well, I don't know how to go from 12 to 15 using multiplication. Well, do you know how to go from 3 to 15 using multiplication? Aha, you can do 3 times 5, which gives you 15. So to keep it equivalent, I need to go from this first number to this blank spot. So 3/4 times 5 gives you what? 3/4 times 5, or 5 over 1. 15/4. And I'm going to leave it as that right now. Okay. And then we need to figure out this last blank. So you might be looking at like, well, I don't know how to get to 5/4 here. Look at the relationship between 15/4 and 5/4. How could you go from 15/4 to 5/4? Could you simply divide by 3 to get there? Well, some of you might say, well, yeah, Mr. Gillis, divide by 3. On bottom, you have to divide by 3 on top to give you 5. And if you needed to check, again, do like I was doing here and show your work on the side. So now I've got this complete. It says then write the equivalent ratios. So here's my first ratio, 3 to 3/4. So let's write that. 3 to 3/4 is equivalent to, my next ratio is 12 to 3, which is equivalent to, my next ratio is 15 to 15/4, which is equivalent to my last ratio, which is 5 to 5/4. There we have our ratios all written as equivalent ratios. Basically, we took this table and we said this equals this, which equals this, which equals this. Same as what I did up here. I could take this a step further, right? I could cut this pizza into 8 slices. And I could say that is equivalent to eating 4 out of 8 slices. Okay. Same difference there. Sorry for the interruption here.
Extension 117. Thank you.
But why don't you pause the video now to try 2 and 3 here using kind of the same method. All right, let's check and see if you did them right. How do you go from 4 to 16? Well, you multiply by 4. So you multiply by 4 up here. And that would give you 5. 5 halves times 4 would give you 10. Come on, right here for me. Oh, sorry if you're seeing this error, guys. It says that Microsoft is restarting, so just give me a second here, and I'll try to work out the kinks. Oh, we're back. Let's see if it works now. Look at there. All right, so we multiply by 4 on top and bottom. And then, how do we go from 10 to 5? Well, let's use division now. We divide by 2. So if we divide by 2 on bottom, that would give us 8. Okay, so to write the equivalent ratios, this time I'm going to use fractions. 5 halves compared to 4 is equivalent to 10 to 16, which is equivalent to 5 eighths. Okay. Oh man, Microsoft really is being a little bit wonky here on me. Sorry about that. All right, this one, to go from 0.4 to 1.2, if you just ignored the decimals, it looks like 4 and 12, right? So you could just multiply by 3 on top and bottom. So that would give you 2.25. Oops, 2.25, Mr. Gillis. And then to go from 0.4 to 1.6, again, ignore the decimals, times 4. So times 4. 0.75 times 4 would give you 3. Okay. And again, rewrite those equivalents. So 0.4 to 0.75 is equivalent to 1.2 to 2.25, which is equivalent to 1.6 to 3. And maybe it's like for every 3 days that you drive, you use 1.6 gallons. Maybe you're not going very far, right? Okay, last example here. It says, excuse me, you mix 1/2 cup of yellow paint for every 3/4 cup blue paint to make 15 total cups of green paint. How much yellow paint do you use? Okay, so some of you are saying, well, 1/2 plus 3/4, that's not 15, Mr. Gillis. Well, no, we're going to use this ratio to find our new total, right? So let's see if I have a yellow here. That's not too blinding. Let's make a table. I've got yellow paint, and I've got blue paint, and I'm going to make, when I mix those two together, I'm going to make green paint. Okay. It tells me that to make the correct ratio, I need 1/2 cup of yellow paint and 3/4 cup of blue paint. Okay, if I just added 1/2 and 3/4, what would I end up with if I just added those two? Well, this is the same as 2/4. So 2/4 plus 3/4 would give me 5/4 cups. Well, I don't want 5/4 cups. I want more than that, right? 5/4 of a cup equals, if I were to change that into a mixed number, 1 1/4 cup of paint. Is that enough? No, I want 15 total cups. So I'm going to put that down here in my table. In the end, I want 15 cups of green paint. But I need to make sure I use the correct ratio of yellow to blue. If I use too much yellow, my green will be too light. If I use too much blue, my green will be too dark. So I need to use this correct ratio. All right. So how do I do that? How do I go from 5/4 cup to 15 cups? Well, I know that I could go from 5/4. I could multiply this by a certain number to get to another number that could easily get to 15. Okay? So what I'm thinking is if I took my 1 1/4 cups or 5/4 cups and I multiplied that by, if I multiplied it by my denominator by 4, what would happen? What's 5/4 times 4? Well, 5 times 4 is 20 over 4 times 1 is 4. What's 20 divided by 4? A nice whole number. So if I were to take 5/4 and I multiply it by 4, it would give me 5 cups. And I know I can easily go from 5 to 15 by multiplying by 3. Okay. Let's multiply our yellow and blue first by 4 to keep our ratio proportionate, and then by 3 to see how much we'd need for 15 total cups. Okay, if I were to multiply a half times 4, or the same thing as what's half of 4, I'd get 2 cups. And what's 3/4 times 4? 3/4 times 4 over 1. 12/4, which is 3 cups. Okay? And does that make sense? Is 2 plus 3 5? Absolutely. Look at how that worked out. Okay? And so if I use 2 cups of yellow and 3 cups of blue, that'd give me 5 total cups of green, and that'd be the right ratio. But I don't want 5 cups again, I want 15. So that's why I multiply by 3. So 2 times 3 would give me 6 cups of yellow, and 3 times 3 would give me 9 cups of blue. So when I add 6 and 19, I do get 15, and it's that same ratio as what I started with. Okay, so the question asks, how much yellow paint do you use? You use 6 cups of yellow paint. Alrighty, that does it for 5.1 and ratio tables. Please let me know if you need more help, and I'll be happy to do so. I'll see you guys next time.